Thanks very much, Tudor. I'm here today to tell you about the Nexus minerals and our future-facing mineral exploration activities. Nexus Minerals has 325 million shares on offer, roughly 16 cents, giving us a market cap of around the $52 million. And with cash at the end of last year of just on $7 million, it's a very solid and strong position for the company to be in. Add that a board and management team with well over 100 years combined mineral exploration and mining experience, and it's a very solid company base. Our company projects, as just previously described, we've been in the Eastern Goldfields now for the last nearly 10 years. Had success over there in mineral exploration, gold exploration in that part of the world. And about 2 years ago, we moved over to Victoria and started looking for large porphyry copper gold deposits over there, and have recently added the critical mineral search of lithium, cesium, tantalum and tin. And you can see in the eastern states there, it's a very large package that we've just put together. So when we first moved to Victoria, it was on the basis of this Bethanga porphyry copper project. Large exploration tenement for a start, located in premier Australian porphyry copper geological terrain, the same terrain as Cadia Ridgeway, North Parks, fantastic projects. And the mineralised belt continues all the way down through New South Wales and into Victoria. Victorian State Government and Geological Survey has been doing a lot of work in promoting and working its region, and how positive it is and how prospective it is for both porphyry copper and VHMS deposits. And the right rocks is something that's been the Nexus catch cry since I joined, and has always been that in my whole career. You need to start with the right rocks, get your technology right, get your details right, and then the success will follow. So Bethanga region was historically mined for copper and gold at the turn of the century, and there's been no modern exploration at all there. So you need to start with your exploration model. Typically, gold, copper porphyries display this magnetic potassic zone at the core of the system and contain minerals, like magnetite, biotite and K-spar. The potassic zone is often surrounded by this non-metallic phyllic zone containing quartz and a lot of sericite and white micas, and that extends outward further again to propylitic, which contains predominantly chlorite but also epidote and carbonate. And we then get a magnetic response where we have a magnetic high over the potassic zone and a low which surrounds it. And at a high level, what we've seen at the end of this porphyry fertility study is that we've had hydrothermal alteration of feldspars converting to white micas, which has provided us with our phyllic zone. Outside of that, we've seen amphiboles, pyroxenes, hydrothermally altered to chlorite, so that puts us in our propylitic zone. And we've got a mineral assemblage of antimony, bismuth and tellurium. So where we've got the eroded Bethanga topography there, that's sort of factually based, even though it's an exploration model at this point in time. The fertility has been positive right the way through. Normally we're looking for 10 to 12 different components of any fertility study, and you'd like to see them have the green tick, and certainly we've been fortunate with the whole Bethanga assessment study has provided us with positivity right the way through. Outcome being that it is highly prospective for hosting a porphyry copper system. Drill targets have been identified, and we're diamond drill planning underway. Only as recently as last week, we've received permission from the local landowner, who owns literally all of the ground within our multi-element zone, which is our area where we want to start drilling, to undertake as many and extensive drilling activities on his property. So that was sort of the last tick that we needed to get that access. Our rocks are all the right rocks. The geochemistry indicates the intrusive rocks are placed in the correct porphyry environment, and our soil geochemistry has returned commodity and trace element enrichments, as you'd expect to see in the upper levels of a porphyry copper system. And our elemental association, magmatic hydrothermal fluids originating from this fertile porphyry system. So very technical, I realise, and that's the sort of basis for what we're doing, but that is porphyry coppers. These need a lot of technical basis and exploration activities before you start drilling them, and then you need to have this solid base, which I think is what we're starting to build up and prove that we have. Our geophysics then, the porphyry target zone covers a decent area, 8 by 3 kilometres, with a high priority zone of 3 by 1.5. And this is what we're showing here, where we've got aeromag and ground mag work, has shown that we've got this magnetic high in the dark red, which could potentially be our potassic zone or the core of our system. And surrounding it, we've got the blue being the low, showing that it could represent the phyllic zone where we're seeing the white micro alteration. So as we've gone forward, each of these has continued to give us positive results and give us encouragement to keep pressing on. And this is where it gets from a scientific point of view and from a porphyry copper hunter point of view, of which I'm well and truly one of these. When we first started here, we've got this Bathanganesis rock type, which we know is about 480 million years old. So it's very distinct in its location, even though it's part of this ormeometamorphic complex. It's got a very distinct mineral assemblage, being this cordierite garnet, and it's the sillimanite K feldspar grade alteration. That's a mouthful. But what it really shows you, that you've got very high temperature minerals, very high temperature grade of metamorphism. However, the Bathanganese itself was produced or was formed at a pressure of about 3.5 kbar and a depth of around 10 to 12 kilometres. Problem with that is that the Bathanganese mineralogy that I just spoke about can only form at a 7 kbar temp pressure and a depth of over 20 kilometres. So you've got a real mismatch in the mineralogy that we're seeing in the rocks versus how and where all the rocks were supposed to have formed. So to have such high temperature minerals at such shallow crustal levels, having this very high geothermal gradient, giving you that sillimanite K feldspar grade, you really need large amounts of mantle-derived magmas to have intruded into the shallow crustal parts. And that's the opportunity here, and that's the exploration model that we're seeing. We're looking for these I-type plutons, Silurian, 420 million years ago intrusions that have come up and pushed their way up into the country rocks, provided the alteration, the changing in the mineralogy, and brought the mineralisation with them. So this will be tested as we move forward. So as we can see, it's a model, and it'll be tested with a drill program in the near future. So the porphyry copper project, fertility study positive, all the geophysics, the geochemistry all looks good. Very technical team that's involved in it, and it's going to hopefully yield us results. So diamond drill planning underway, and news to follow as we get that organised and get the rigs on the ground. Our critical mineral search, and this is definitely a first mover advantage in the eastern part of Australia. We've been granted recently over 15,000 square kilometres of tenure in northeastern Victoria and New South Wales, and we're looking for this lithium, caesium, tantalum, tin and copper. The LCT pegmatites are typically associated with these highly fractionated S-type Silurian granites, which we were just talking about in and around Bathanga, and the Wagga Ormeo zone in particular, which is host to emplacement of that era of intrusives. So we did a high-level study of the whole of eastern Australia to determine, okay, where is the most likely and most prospective ground where we're going to see these LCT pegmatites. The Wagga Ormeo zone came up as trumps, that looked the part. We know from some recent discoveries in the Wagga Ormeo zone in Victoria that lithium-bearing pegmatites exist, and so we've extended that into New South Wales, and we're certainly surprised that when we actually went to peg the ground, that over 15,000 square Ks was available to us and have been unpegged. Regional scale, first mover advantage, largest pegging exercise in New South Wales history, and with the tenure perspective for our LCT pegmatites and tin. There's a core of tin mines you can see there in tenure that's not part of ours that we've just pegged, and that just shows you that the Silurian style of granite that we're looking for are the ones that we're seeing. So hence highly prospective. Review the open file geology, determined that this was the place to be, and typically these LCT pegmatites occur 3 to 6 kilometres from the contact of these intrusions. So that's quite important, as you can imagine, from our field investigation work that's going to follow. We need to know where the contacts are, then get on the ground with an XRF and hunt down these LCT pegmatites. This is the Victorian component, and we can see that the Dorchap range, which I've got highlighted, it's about an hour south of Albury-Wodonga in Victoria. Lithium-bearing pegmatites been discovered there, and the company is actually or Dart Mining is actually drilling there as we speak, and we've just put out an announcement today showing some good pegmatites at depth there. So by extension, we know that there's intrusive Silurian granites in the district, and hence that's going to be our exploration model. Grania we've been granted, and it hosts this Thalogga-long Silurian granite again. So we're exploring 3 to 6 kilometres away. We've identified extensive pegmatites on the ground. Mapping and sampling programs underway, and this XRF orientation survey will commence once we get the unit over there in about the 3rd week of April. So initially it's a matter of getting on the ground, doing the geological work, whacking the rocks, starting orientation surveys, and then start doing these the XRF work and later in the month. Merrimack was a project that we've just taken now under abutting our application tenement in Victoria. This Mount Wills granite that you can see there, it's this intrusive, the correct aged intrusive, permissive, suitable for fertile LCT pegmatites, and the ground to the north of it, held by another entity, the Dorchap LCT pegmatite swarm. And you can see there we're looking for this 3 to 6 kilometres again from the contact zone, and that's a line already of historical tin pegmatites there. So it's a matter of the same thing, getting on the ground and then starting the orientation survey. The work plan then, the porphyry fertility assessment has all come up positive at Bathanga. Diamond drill targets identified, and we'll get our drill program completed this quarter and hopefully get the program started in the second half of the year. It'll be a large-scale, significant, deep diamond drill program, so a fair bit of work needs to go into it before we hit the ground. The LCT pegmatite search through New South Wales, regional geochemistry, regional geophysical data sets brought together, determine where the contacts are between these permissive granites, and then start hitting the ground and doing ground truthing. Grania and Merrimack were already on the ground. We've got 2 crews over there right now, and we'll wait for the granting of the final part of the tenure. So by summary, Victoria and New South Wales critical mineral search, Bathanga porphyry copper, very positive fertility assessment, and we are drill ready. The LCT pegmatite search through New South Wales, 15,000 square kilometres, recently granted. Commenced work there. Grania and Merrimack, we're on the ground exploring as we speak. And in Victoria, we'll wait for this final parts of the tenement package that are under application. So Nexus Minerals continues to have the quality projects, certainly the right rocks, a professional management experienced management team, and we're well funded with $7 million cash on hand. So thank you much for your time.